Hello everyone. Our today's topic is torque. We had already discussed about dipole and the field created by dipole at an axial and an equatorial point. Today we are going to discuss about torque. Now what is a torque? Whenever, here you can see a dipole kept in a uniform electric field. So here these are all electric field lines and it is a uniform electric field. What is the meaning of uniform electric field? Uniform electric field means the lines can be represented in this manner. They are in the same direction and equal distances apart. Okay. But when you see lines like this, these are non-uniform electric field lines. So here the dipole is kept in a uniform electric field and they are at a distance 2L apart. Here you can see they are at a distance 2L apart and minus q is here and plus q is here. And they are inclined. They are inclined with the electric field by an angle theta. They are inclined on the electric field by an angle theta. Here you can see the angle as theta. Now what happens when a dipole is kept in an uniform electric field? So it is seen that when the dipole is kept in this manner, a torque acts on the dipole and it tries to align the dipole in the direction of the field. If this is the dipole, a torque will act upon it and will try to align it in the direction of the field, or we can say it will try to bring it in the direction of the field. So let us see how we can deduce the formula for torque. So first of all, we have to find out the net force acting on the dipole. So for that, we can see that force on plus q charge, force acting on the charge plus q when placed in an electric field will be QE. Okay, and it will be along this direction. This force will be along QE, will be along this direction. Okay, which is along the field, which will be directed along the field, and force on minus q charge will be f of minus q equals to minus QE. It is directed away, or we can write opposite to the field. Therefore, net force F will be what? So QE minus of QE will be 0. So we can see that there is no net force acting on the dipole. That means there is no translatory force acting on the dipole. But the force is 0. But still, okay, here another thing let me mention. The QE force will be along this direction. Okay, along this direction of this. Okay, so the net force is 0. But still a couple will act on the dipole. Since you know couple can be represented in this manner, if a force is in this direction, another force is in this direction, it will form a couple. These two forces are equal and opposite, and it will try to rotate the dipole. A couple, since you see, let us erase this portion. Please pause it and see it if you are unable to understand. So we are erasing this portion now. Here you can see this dipole is in this manner. So here one force is acting and here one force is acting. These two are, the net force is 0, but these two are in equal and opposite direction. Okay, if this is F, the magnitude is same, both is QE. So these two are equal and opposite, and these two are forming a couple which will try to rotate the dipole. Okay. Now this couple will exert a torque. The couple will exert a torque on the dipole. Okay, so what is the formula of torque? Torque means either force. In a couple, since both the forces are of same magnitude, you can take either force. So torque is represented by tau, means either force into perpendicular distance between the forces. So what is the perpendicular between the forces? Here you can see this is the perpendicular between the forces. If this is the force, this is another force. So the distance between these two will be what? 2L sine theta. Why? Since this is theta, so what you can say, sine theta will be perpendicular by hypotenuse. Hypotenuse is what? 2L. So perpendicular's value will be 2L. Perpendicular's value will be 2L sine theta. So to find the value of perpendicular, we can put the value of sine theta in this manner. Then we will get the value of P, and P is perpendicular distance. So in that manner we get 12 sine theta. So either force we take it. So force QE into 2L sine theta. Okay, so here we are not putting cross product but the normal multiplication sign. Okay, so next you can arrange it in this manner. E2QL sine theta. E2QL sine theta. Now you see this 2QL, we are acquainted with this 2QL. This is equals to P sine theta. Now let us arrange it little bit. Equals to PE sine theta. So this is the value of tau. So tau equals to PE sine theta. Okay. Now if you want to write tau vectorially, so vectorially tau will be given by tau equals to, now you see PE sine theta. So sine theta comes in the cross product. So we can write P cross E. We know if P cross E is P cross product of E gives us PE sine theta. So this is our final formula. So tau vector equals to dipole moment vector into electric field vector. Okay, so this is how, and this is the torque exerted on the dipole. So now, let us see once how did we get torque. So tau equals to either force into perpendicular distance between the forces. So either force magnitude is what? QE. Net force is 0, but either of the forces has a value, and that is QE. So that is into 2L sin theta. So E into 2QL sin theta. After rearranging, we will get in place of 2QL P, since P equals to 2QL. Okay. So we put the values, and in scalar form we can write tau equals to P sin theta, and vector form we can write tau equals to P cross E. Now, when will tau be maximum and when will it be minimum? Let us see. So tau equals to P cross E. This is our main formula. So now tau will be maximum when theta's value will be 90 degree. So you can, because we know sin theta has the maximum value. So obviously sin theta has the maximum value at 90 degree. So obviously if we write PE sin theta, if we write here 90 degree, we will get the maximum value. So tau equals to PE, and this is the maximum value of tau. That means the torque will be maximum when the dipole is perpendicular to the field. If this is your field, and when the torque is at an angle of 90 degree with respect to the field, then the dipole is at an angle 90 degree with respect to the field, then torque will be maximum. And when will it be minimum? So if the field direction is like this and the torque is also like this, the dipole is also like this, that means it is making an angle theta with the electric field, then we can say tau has a minimum value. That means, so in this case tau equals to PE sin theta. So sin theta is equals to 0. So tau equals to 0. This is the minimum value of tau. Okay, that means when the dipole is kept parallel to the field, then we will get the minimum value of torque. And another thing you have to remember, this is the case of uniform electric field. In a non-uniform electric field, the net force is not 0. Okay, and here the net force is 0 in a uniform electric field, but in a non-uniform electric field, the net force is not 0 and the tau is again not 0. Okay, so this you have to remember. So that's all for today. Thank you.